Alright, trig class, now we're going to look at the general formula. So now we are, if you look at the question, we don't have that 0 to 2 pi restriction. So now there is nothing that's going to stop the angle from rotating around over and over again infinitely many times. So with a sine function, remember sine is the y coordinates. So when we have sine is equal to negative square root of 3 over 2, it's just you're being asked where is the y coordinate equal to the negative square root of 3 over 2. What angles make that happen? And if you look, it happens right here. There's a y coordinate of negative square root of 3 over 2, but there it happens again. So for both of these angles, 4 pi over 3 and 5 pi over 3, the y coordinate is the negative square root of 3 over 2. So those are the two foundational angles. But after we start there, because we could just keep going around in a circle, we would be adding 2 pi or possibly again subtracting 2 pi. So we do 2 pi times k, and k allows us to go around again and again and again and again. You know, k could be any integer, and that's what it says right here. K is an integer. And then we also had the 5 pi over 3. Now you have to understand that there isn't a general formula for both of these, like that will give you all of the angles. We're going to have to do them independently. We're going to have the first angle, and we're going to have the second angle, and independently we add 2 pi k to each one of those. These are pi over 3 units apart. These are 5 pi over 3 units apart. So it's like pi over 3, 5, adding pi over 3, adding 5 pi over 3, adding pi over 3, adding 5 pi over 3. And so since it's different between each one, we don't try to come up with a single formula for all of them. We do two individuals. All right, it says based on the smaller angle. So again, on ours, the smaller angle is that 4 pi over 3. So I'm going to do 4 pi over 3, and then I'm going to add plus 2 pi times k. All right, so that's what we have to write to get it to continue going around and around and around the circle. All right, now it wants to do the larger angle. So we're doing them independently. So now we're doing the 5 pi over 3. But we're going to do the same thing. It's 5 pi over 3 plus 2 pi k. All right, again, k is what allows us to keep adding 2 pi over and over, or subtracting 2 pi over and over. All right, list the first 6 solutions that are greater than or equal to 0. So this is where like a TI can help you, because you're going to be adding 2 pi over and over to these two angles. So again, when you're going to use the TI to help you with this stuff, I encourage you, don't put the pi in there. 4 pi over 3, all right, and then plus 2 pi would just be plus 2. All right, change it into a fraction. So math 1, change it into a fraction. So 10 pi over 3. All right, so 4 pi over 3, I'm just adding, you can think of it, I'm adding 6 pi over 3. That's 2 pi to this over and over. So all the numerators that started off with a 4 are going to go up by 6 at a time. So 4, 10, 16. All right, since I'm doing the first 6, there's going to be 3 from the 4 pi over 3, and then 3 from the 5 pi over 3. And each time we're just adding 6. So there's 4 pi over 3. I'm going to do a comma. 5 pi over 3 is going to be there. I'm going to do a space. I just want you to see I'm doing the 4 pi over 3, like the leapfrogging the 5 pi over 3. So 4 pi over 3, if I add 2 pi, which again is 6 pi over 3, I get to 10 pi over 3. All right, comma. That would be, again, the next one would come from 5 pi over 3. I'm leapfrogging that one and doing the last one from 4 pi over 3, which again, adding 6 pi over 3 to this, I'd have 16 pi over 3. All right, so there's 3 that came from the 4 pi over 3. Now I'm going to switch to color. Now this is 5 pi over 3. Again, I would be adding 2 pi, which is 6 pi over 3. So adding that to that, I would just be one more than the numerator, just like I was here for the next one. So I'd be at 11 pi over 3. And then the next one here would be 17 pi over 3. So there is going to be my first 6 solutions greater than 0. 4, 5, 10, 11, 16, 17, and the pi over 3's for all those. Alright, so there they all are typed in there. Oops, and do make sure that you put a comma. I forgot to put a comma between these. It would have counted it wrong if I wouldn't have had that comma in there. So that is a way that you can do it. You could do this all with the calculator, just adding 2. All right, just remember to stick the pi's back in the numerator if you need help with the calculator with that.